All right, let's get right into it. Today, we're tackling one of the biggest, most important decisions you'll face on any AI project, picking the right vector infrastructure. We're not just going to talk about it, we're going to build a decision framework you can actually use. So let's start with this question, because really this is everything. In the world of AI, your vector database is like the brain's library. It's how your model finds what it needs based on meaning, not just simple keywords. And if you choose the wrong library, well, your AI won't be as smart as it could be. It's that fundamental. So, to make sure we're all on the same page, what are we even talking about? A vector database stores and searches something called embeddings. You can just think of these as numerical fingerprints for all your unstructured stuff. Text, pictures, audio, you name it. The database's whole job is to find similar fingerprints and do it ridiculously fast. Okay, here's our game plan for today. We'll start with why this is such a huge deal right now. Then we'll walk through the big decisions: specialized versus integrated systems, control versus convenience. We'll look under the hood at the tech, and then we'll wrap it all up in that decision framework I promised. So first up, why is everybody talking about this right now? It's pretty simple, actually. Every single time you ask a generative AI to do something with your own data, like summarize a report or find a specific image, it's using vector technology. It's the critical backbone that lets AI understand what you mean. And wow, the market definitely shows it. We're talking about a market that was already at $1.8 billion in 2023 and is expected to explode to over $13 billion in the next decade. This isn't just a flash in the pan. It's a massive foundational shift in how we build software. And here's the absolute key to understanding this shift. Traditional databases, they're built for structured data and exact matches. Think, find the user with ID number 123. But vector databases, they're built for something totally different: semantic similarity. They answer questions like, find me a song that feels like this one, even if the words are totally different. It's about meaning. Okay, so that brings us to our first major fork in the road. This is a big one. Do you go out and add a brand new specialized vector database to your system? Or do you just use the vector features that are now being built into the databases you probably already have, like Postgres or Mongo? This slide just lays it all out perfectly. On one side, you have the specialized tools like Pinecone. They're built for one thing, and they do it better than anyone: peak performance. On the other side, you've got integrated solutions like PGVector, which offer beautiful simplicity. It's a classic battle: raw, unadulterated power versus making your life a whole lot easier. And this trade-off is driving a huge trend in the market. It's called the architectural simplicity premium. And it basically means that for a lot of teams, the headache and the cost of managing a whole separate database just for vectors, it just isn't worth the tiny performance boost you might get. Simplicity is winning. Now, let's move on to our next decision, which is very closely related. Do you want the absolute total control that comes with hosting an open source tool yourself, or do you prefer the convenience of a managed service? And really, this all comes down to one thing: the total cost of ownership. And this is where things get really, really interesting. Look at that first row: initial cost. For open source, it says free. And sure, the software is free to download, but the true cost of actually running it, well, that tells a very, very different story. Let's put a number on it. For a pretty typical self-hosted setup, you could be looking at almost $19,000 a month. And that's not just paying for servers. That number includes the salary for a highly skilled DevOps engineer, the person you need to hire just to keep the whole thing running smoothly. Now compare that to a managed solution. Yeah, you pay a subscription fee, but your total cost can be less than half because you're not paying for all that operational complexity. The vendor handles it. So you're trading a little bit of control for a much faster time to production and a way lower total cost. Okay, so you've made your big picture architectural choices. Now let's pop the hood. How in the world do these things search through millions or billions of items so fast? Let's demystify the tech. The magic behind all of this is an algorithm called approximate nearest neighbor, or ANN. Here's the deal. Finding the one perfect match in a billion items would just take way too long. So ANN makes a tiny trade-off. It sacrifices a minuscule amount of accuracy to give you a close enough answer, which is still incredibly accurate, by the way, in a fraction of the time. Right now, the most popular way to do this is with an algorithm called HNSW. And the analogy here is just perfect. Think of it like a GPS for your data. It builds a map with different layers. The top layers are like interstate highways. They get you across the country fast. And the bottom layers are the local roads that get you right to the specific doorstep with absolute precision. Another really common approach is called IVF Flat. This one is super clever. It starts by sorting all your similar data points into different buckets. Then, when a search comes in, it figures out which one or two buckets are the most relevant and only searches inside those. It just ignores everything else, which makes it blazing fast. And hey, if you choose that self-hosted open source route, well, this slide is your new life. You're not just a user anymore. You're a tuner. You're constantly turning these knobs, balancing memory usage and speed and cost. This is that specialized expertise we talked about earlier, and it's a huge part of that total cost of ownership. All right, we've been through the why, the what, and the how. Let's pull all of this together into a clear, simple framework that you can actually take back to your team and use today. It's really just a simple 4-step process. 1. Pick your architecture, specialized or integrated. 2. Choose your model, managed or self-hosted. 3. Get real about your performance needs. What do you actually require? And 4. Map it all to the right solution. And here it is, the final framework in action. This is basically your cheat sheet. Just find your use case on the left. Are you just trying to build a prototype quickly? A managed service like Pinecone is probably your best bet. Is all your data already living in Postgres? Well, PGVector is the path of least resistance. Building from massive planet scale, you're probably going to need the control of a self-hosted tool like Milvus. But here's the real pro tip, the thing the smartest teams are doing. This is not a winner-take-all game. The best strategy is often a hybrid one. You might use a simple open-source tool like Chroma for your local development, spin up a managed service to prototype an idea, and then run a high-control self-hosted solution for your main production app. You use the right tool for the job. So there you have it. That's the map to the entire vector infrastructure landscape. Choosing the right path isn't just some technical detail. It's a strategic decision that will literally define how smart your applications can be. So the only question left is, where are you going to point your AI next?